Hello guys, I think we are live now, so let's test it out. As usual, just gonna open some terminal stuff. Ooh. Yeah, I think we are live now, so let's test it. There you go. How's everyone doing? It's good to be here on this Tuesday evening. Yeah, I'm looking forward to doing some coding. So today we're gonna be working mostly on the 6502 emulator that we've been kind of like, it's a long-term project of the channel here. Hello, Most Light Dude. Oh, it's good to see you, man. It's good to see you from minute zero. I hope you're ready to do some C++, my man. How are you doing, man? How was your weekend? Did you have a nice weekend? Let me get the project up. There's been quite a few changes here, by the way. So I've actually really picked up on contributing to this project. So I've done like quite a lot of opcode support here. There's only like a few different ones. I think overall there is something like 156 opcodes in general, and there's only like 10, 15 or so that needs to actually be done. So yeah, I've basically picked up on trying to finish this project because I'm getting sick of this. I'm always here, mate. Yeah, it's just busy, man. Yeah, I can imagine, man. So for me as well, it's getting very busy, getting very busy. Like busy on fucking weekdays, and then when we're not on weekdays, we just have like events and whatnot, like people's birthdays and stuff, which is seems to be quite annoying right now, if I'm honest. But yeah. So how do I edit the video? Okay, I forgot to turn monetization, so I wouldn't be getting any money from this. Not that I get anything anyway, but now we have ads. Now we have ads. But yeah, so there's been quite a lot of changes in this project. So this is, for those who don't know, I have started a 6502 emulator, maybe something like, I don't know, 5 months ago now. I'm not too sure. And I've kind of given it a pause because I got really kind of tired of doing the same work over and over again. But more recently, in the past month or so, I really started trying to finish this project. So in fact, if you take a look at my profile and all of the, what the hell is this? This is terrible dark mode for this image. Yeah, but if you take a look at my GitHub profile, you can see that I've kind of picked up in the last month or so, and this is entirely trying to finish this project here. Because yeah, sometimes I don't finish projects, and that really annoys me. And I'm not gonna let this project be one of those that I just started and never finished. To be honest, mostly I can't imagine what we've been through, man. Coding at work, coding at home. I'm just getting tired, man. That is true, must lie. That is true, dude. So what coding do you do again? You're a front end or back end developer? Like I know that I've got quite a few people watching me who do back-end engineering with Golang and TypeScript, but I'm not sure which one you are. But point is, we're all in the same boat, right? So it's enjoying code on your free time is a blessing and a curse, right? It's a blessing in the sense that you tend to pick up things a bit faster, right? Just because you actually enjoy doing it and you're doing it all the time. So you know more stuff as well. But it's a curse in the sense that you can't really switch off, right? So you finish work, and then you're thinking about what you're going to do today or which project you're going to try and work on or put some hours in. And yeah, I mean, I feel you, man. I feel you. I'm just going to turn up the flash here so you guys can see my face better. Mostly front end. I'm not smart for a back end. I don't think you need to be smart for back end, man. I think front end is just as hard. You still have like a lot of problems to solve. And at the end of the day, let's be honest, both front end and back end engineering, as well as systems engineering, which is what I do, all you do is like you mostly Google things online and you learn how those things work, and then you replicate it on your work. That's it, really. It's kind of the same problem. But anyway, so yeah, I mean, today's work will be basically supporting some more comparison functions here, right? So these functions, these opcodes here. So comparison functions in 6502, or comparison opcodes, are basically assembly opcodes that will basically take the state of the CPU, and then it will check the memory that you give it against some sort of register, right? So in this case here, we'll compare it with the accumulator. So this opcode will basically, take whatever's in the accumulator. Let's see if we can draw it here. Do we have a little Excalibur? I love an Excalibur session, don't we? So we love Excalibur. In fact, I should already have. There you go. So we already have something. Yay. I knew that this would be useful at some point. And this is from like months ago. So this is what the CPU looks like. This is what the 6502 CPU looks like. These are the registers, right? So these are the registers that you have accessible to you. Most of them are 8-bit, except the PC. The program counter is a 16-bit register. So obviously you have 16 bits worth of addresses that you can access. The rest of them are 8-bit. So say we have the accumulator, and the accumulator is equal to, I don't know. Wait, what did I just do? This dark mode is terrible, man. So the accumulator is equal to this, right? So we say we have FF. So what CPM will do is CPM will, let's just CMP, yeah, CMP, and say we do 0x, I don't know, FE or something. So if we pass in this instruction here to our emulator, in fact, it should be something like this. Something like that, I think. If we have this, then we will take the memory or the value FE and we'll compare it against AC. And what the comparison does is it will set some flags based on whether or not it's equals or less than, I believe. And the flags that we will set will be these ones here. So, you know, this is what happens when you branch. So you do a comparison, and then based on whether or not the value that you wanted to check against the accumulator is the same or is different or is less than or if anything like that, then you're going to branch over some code. So you're going to like jump around in the code. And this is essentially how if statements work. If you think about if statements in your programming language of choice, so C++, JavaScript, Golang, whatever you're watching me for, those if statements will compile down to assembly comparison functions and branching functions. So this is the 6502 version of the comparison stuff. That's what we're doing here, right? This is just a little bit of lesson, a little bit of background on what we're going to be doing today. In fact, I hope it's not going to be hard work anyway, because we've already got some of these implementations. So I've already support some of those comparison functions in here. So you can see that I support the comparison for the X register, the Y registers. The only things that I don't support are the different addressing modes. So, you know, we can go over the addressing modes if you want, but this is like different ways of indirection within assembly in 6502. And each indirection, each different type of indirection, or each different type of getting that memory that you're comparing it with, has a different opcode, right? So let's go for that. 65K. And I'm actually going to create a branch that we're going to be working on right now. By the way, does anyone know here? Does anyone here knows assembly? Has anyone done assembly before? Please message in the chat if you have, because you might be useful. I don't really know much assembly, to be honest. All I know is from like watching the Godbolt compiler explorer compile down my very sort of minimized versions of C++ code. So I don't really know that much, to be honest. Git checkout SP. What is this? Adding remaining CMP opcodes. Do you guys ever get like some days it just feels amazing to write on your keyboard or to type on your keyboard? I have zero clue. I love Must Light. That's why you hear Must Light, so you can learn how all of this works. So yeah, some days it feels really nice to write on my keyboard, and I don't even have to look down on the keyboard to actually find my way around it. And then some days I just can't type, and then my fingers will just be at the wrong place all of the time, and I make loads of typos. Is there a way to kind of reduce that? Do you guys know of any good ways to reduce the, you know, to improve typing on your keyboard, but not in the sense of like knowing your way around it, just getting to the, what's the word? Like getting into the habit of knowing your keyboard, if it makes sense. Because it takes me, I feel like it takes me maybe 1 or 2 hours during my day to actually get into the state where I can, you know, touch type. But yeah, I'm not sure. And okay, so we've got that. And we're going to check how mass works. So if for those who are interested in knowing a little bit more about 6502, there is this website called Masswork, and this has tables on every single instruction that you can possibly get, right? So yeah, let's try that. And we're looking for the CMP, right? CMP. Yeah, compare memory. In particular, we're looking for, I guess, I don't know which one was it again. I'm just looking at the number of cycles and stuff. That's not the right page. This is the right page. So the first one is D5. So we're looking at D5, which is the 0-page indexed. So this operation will take an 8-bit, aside from the command assembly itself, so the command bytes, we also take another byte, which is the 0-page address, and this will implicitly be added to X, and then that will be the final address of the memory that you want to compare, right? This is what this addressing mode is, and what does it do here? So this will essentially, this operation does A minus M. This is how the comparison works, right? So if the results of whatever is in the accumulator, so the results of whatever is in, oh, please Bitdefender, what the fuck? I should swear, I should not swear. So if the results of whatever is in the accumulator minus whatever is in the memory that you pass in here, so the memory address, is negative, then the flag is set, right? A negative here means 2's complement. For those who know what 2's complement is, this is how negative values are stored in 6502, I believe. If the result is 0, so if they're both the same, this 0 flag will be set, right? And if there is a carry, I don't know when there might be a carry in subtraction, we also set the C flag, right? That's what we do. I think it's related with sleep. If I don't get enough sleep, then it happens to me, but it's like once in a blue moon. Yeah, maybe, yeah. I definitely get it when I'm tired, for sure. Like, whenever I'm tired, I'm absolutely terrible at typing. I was going to swear again, but I'm going to try and zip my mouth this time. I don't want to lose the sponsors, or not the sponsors, but the adverts on the videos. Anyway, so yeah, let's look at how we're currently doing now. So we have CMP media registers. So you can see here that I've already got some of these functions. So CMP immediate reg is already one of them. And there's C9, which means it's for the immediate value. And then we also have the 0-page one, which is this one here. So naturally, right, the next one we can do, because, you know, both the comparison function for accumulator, the comparison function for X register, and the Y register, the ones that they have in common are the absolute ones, the 0-page, and immediate. And I'm pretty sure that I don't have support for the absolute. So that one would kind of kill more birds with the same stone here, if you see what I mean. So I can reuse the same function for this one here, and for this one here. Only what I have to do is essentially just just change the register that we're applying the operation to, right? So we're going to be doing that for sure. So CMP, wait, what is it? CMP 0-page register. I'm going to copy this one. I'm going to paste it down here. CMP absolute. That'll be it. And obviously I need to look for another place where I do absolute, because I'm going to replace some of the code. So with absolute addressing mode, right? So some of these functions here, what you actually get in your emulator, so the actual code that you get in your emulator is a bit for, or a byte for the actual instruction itself. And you also get the operator, which in this case is 2 bytes. So you get a low nibble and a high nibble, right? Which will give you a 16-bit address. This is what you get here, right? This is it. And this is why I'm actually just copying it from a different place, because I don't want to work it out again. I am essentially just gonna, redo it. So this check here is just making sure that whatever program I have, that from the PC counter, so from where the place I am in the program, and by the way, a 6502 program is just, an array of bytes, essentially. From that point onwards, I have at least 2 bytes, right? So after we read the opcode, I have 2 bytes after that, which will be my low and high nibble. This is why this check is here. And then I get low and high nibble, as you can see in here. We get the address itself in here. I'm not going to explain too much. And then we do whatever the hell we have to do in here, which is just the address, I guess. Right, and I think that was it. All right, so ideally, right, all of these functions do the same operation, as you can see here. So they all set the flag in the same way. They all set this. So we can do some, I guess, some refactoring here already, right? Because I want to make sure that there's no points of failure. Hello, build your own CNC. You gotta tell me what a CNC is, my man. But yeah, how is it going, man? Welcome to the stream. Good to see you here. In fact, why are you highlighted? Is that why do you highlight? Why are you highlighted? Have you sponsored me or something? Should I be saying thank you? But I'm actually interested, like why your name is highlighted. Wait, do we really not have verified? Oh, you're verified. YouTube verified. Okay, dude, I'm gonna check your channel right now. So go to channel, if that's okay. I'm gonna open up here on the other page. Dude, you've got 102,000 subscribers. I'm gonna subscribe right now, so thank you very much. But yeah, and you seem to have very interesting videos as well, man. Oh, I'm liking it. I'm really liking it. Sure. Yeah, so if you guys don't know him, go subscribe. I am definitely gonna keep it. Oh, how do I do the bell? Personalize. Oh, there you go, man. I'll give you some viewership and I'll give you some comments. Thank you for checking out the stream. Anyway, coming back to this, what we have here, yeah, we're just gonna like abstract the flag setting and the actual comparison operation outside of these functions because they're all going to be using the same, and all of the different addressing modes will use the same operation anyway. So yeah, so I think we'll probably return a void here. Does it need to return anything? I don't think so. And then we're going to do a CMP operation, and we're going to take the emulator CPU as a thing here. Yeah, super interesting videos. Yeah, dude, yeah, the guy's famous, man. Yes, sir, be mums. Guess what? The prodigal son is here. Oh, Peter, hello, dude. How's it going, man? It has literally been months, dude, and I hope that you're doing amazing at university because you've not given me any updates on your course or anything. So hopefully you're doing amazing, right, dude? So yeah, let me know. But it's amazing to see you here again, Peter, and I always enjoy having you here, my man. So Peter is one of those viewers that have been here on the channel maybe since the first month I started streaming, which is quite impressive, to be honest. You know, people keep coming back, and that keeps kind of surprising me because I don't ever think that people want to watch me. But yeah. Anyway, taking the CPU here, we're gonna take the position maybe. Yeah, so std uint at position of the memory, and we're basically just gonna copy all of this out, really. Or in fact, we don't even need the position; we just need the value. Yeah, which is a value there. And we paste that, and then we go in here, do one of this. The value we don't need, we already have that. And whatever we had value before, we're going to change to val, and then, ooh, I fucked up. So we're going to do val g to val g. There you go. That's what I meant to do. Great. Yeah, so that should be able to replace most of these things in here. So comparison is the register minus val. That sounds about right. That is correct, right? That's what the thing says. Yeah, the registers minus the value. And yeah, we can basically replace all of these, I guess. And this will be CMP operation. CMP operation. And then we pass in the CPU in here and also the value. In fact, you know, if we just replace that with just this, I think it's probably all right. I'm going to save some lines basically. Same thing here. We're going to replace this with CMP operation, CPU, and then we have CPU.mem memory. I don't like how I have different names in different functions, but oh no, in fact, this is going to be there. Yeah, okay, and then we also have that being replaced here. So we have CMP operation, We have CPU and on CPU, memory. And my newly added absolute. Yeah, there you go. So CPU, program address. Yeah. So we have everything here. Just gonna format this real quick. There you go. So yeah, I mean, this is cool. This is interesting. I can already kind of see what's going on. This should return the number of bytes the operation takes, and then the cycles as well. So the absolute one will always take 4 cycles. Is that correct? 4 cycles, 4 cycles, and 4 cycles. So I return 3 and 4 here. So it takes 3 bytes. It consumes 3 bytes. So the opcode for the operation, and 1 for the high nibble and the low nibble, and then also the number of cycles here. Right. Cool. So now we can actually add this to the big array that I have. So where is it? It's going to be in here, I guess. Where is it? Where are my comparison functions? Have I found it? No. Where's my comparison functions? Dude, have I missed them? There you go. So they are here. So it's 1572, 1572. And I'm going to just say CMP. CMP opcodes. CMP, CPX, and then CPY opcodes. That's what we have here. And then we are going to basically just do one of these. Replace that with... Now, this is for the absolute... Sorry, this is for the accumulator one. And the accumulator one is here, right? Which is CD. Yeah, CD. What am I? 0x CD. And CMP absolute or C? Absolute. And then we pass in the A register. And obviously we can also do... I'm going to put all the absolutes at the end. We can also do the same for X and Y, right? So we have X and we have Y here. And this will obviously change. So the X one is EC. And the Y one is what? So EC is this one, and the Y is CC, right? Right. So good. Now that also means that we actually have support in here for the absolute. I'm just going to change this to a Y check mark. Y check mark. And we have the same for the CPX absolute. And for this one as well. Okay, just to make sure the preview, now we do have the ticks in there, right? What are we? Yeah, we have the little tick in here. Now, actually, this should have been an okay. I'll tell you why. This should not be this. I'm using this symbol here to identify whenever I have full support for an operation, for an opcode. But full support in my case here means that I actually have the operation supported plus tests. If I don't have the tests, it should just be an okay. It should just be like one of these guys in here, right? Because that means we have operation support but no tests written for it, so I don't really know if they work. It's just the support for it, right? So I'm gonna change it a little bit. Got messages. I'm doing amazing, graduating. Oh, sorry, Peter, I missed the message. I'm doing amazing, graduating in a week time. I'm super hot with my portfolio project for real. Oh, amazing! That's amazing, dude. That is really good to hear. And congratulations on like passing your year and graduation, man. Because it's definitely one of the most like important times of your life. So do enjoy it. Do take it easy. Do celebrate it quite well because you deserve it, man. I remember like every time I was streaming and you were on the stream, you were just like, you had the stream open, but you were really doing work on the background for like hours and hours. And yeah, I mean, I can tell that you worked hard for it, dude. Hello, GTX. How's it going? Hello, can't stream because I'm busy, but I wanted to drop in and say hi. Thank you, dude. Thank you. I do appreciate it very much. If you can drop in and just like the video, if you guys haven't done that yet, just like the video. It does help me out quite a lot. But yeah, man, don't worry if you can't watch it. I know that you can't make it every stream. I don't expect you to either. Definitely focus on your life more than my stream, for sure. Yeah, oh my god. Why is Bitdefender just like spamming me? Jesus Christ. Yeah, this should have been an okay, I'm pretty sure. And okay. And it's the same for this one here. In fact, I'm pretty sure that all of the comparison functions are essentially not tested well. So yeah. I do wonder if I can get ChatGPT to write the test for these. But yeah. Just like, thanks for the reminder. Thank you, William CNC. I do appreciate the support, man. By the way, if you guys are watching as well, there's like 10 people watching. No, 10. Oh, we're down to 8 now. There's 8 people watching. Please check out Build Your Own CNC's channel because it seems like he's got really nice hardware videos. And yeah, I recommend it. Does anyone else want to get a plug here? Does anyone else have a channel that wants to get free advertising on my stream? I guess not. But feel free to advertise it. Okay. I never thought about it. Maybe go into people's streams and then... Yeah, maybe that's a good way to advertise my channel because I'm terrible at advertising. That's why I've only got like 3,000 subscribers or something. I am actually terrible. But yeah, I mean, now we have what? We have okay here. CMP, CMP, CMP. There you go. This should be okay. Okay, good. Now let's think about the next one. So we have essentially got this absolute. Now we're down to just doing the rest of them, right? So first one I want to do is 0 page plus X. And this is very easy, right? I'll tell you guys why it's going to be very, very easy to support these functions here. I've essentially abstracted all of the indirection stuff. So all the, I guess, more complicated indirections here. So 0 page plus X is not necessarily complicated to understand. Neither is absolute or indexed indirect and vice versa. But I already have functions that get the indirection memory for me, so I don't have to work that out by myself. You see that in a second. So essentially, it's just a matter of like plugging and playing like parts of of the addressing mode that I want, and then also the operation that I want to do. And that's basically how I support this. And I do wonder if I can eventually create a backend for any sort of like 8-bit emulator in the future, because all of them, 6502, Z80, and co, they all have very similar operations and they all have very similar architectures, which means that I can basically just abstract this emulator and then allow people to provide, I want this addressing mode and I want this function to do a comparison to the accumulator or whatever and set these flags. So yeah, maybe that's a very good idea for a future project. But yeah, not what we're going to do now, though. I'm just trying to finish this one first. But yeah, CMP, 0 page. Makes sense. Oh yeah, thank you that it makes sense. Sometimes I do wonder if I'm just talking to myself. Usually I have Robin here. Robin is the person who likes 6502 as well. But glad to know that there's someone else who understands it as well. Right. Yeah, so this is what I'm talking about, right? So we have CPM 0 page register. This is just a function that returns me a lambda that manages that opcode. I could do now CPM 0 page indexed in here. And that would be basically copying. The to do here is get the 0 page indexed address. And then apply the CMP operation on the indirection. That's what we're going to do. I have the same problem when I do live streams where there isn't much appearing in chat. I feel like I'm talking to the air. Yeah, so what I found, Build Your Own CNC, is that you should probably get this. If you're on Windows anyway, you should probably get the Power Toys and then put your chat on always on top because it refreshes faster. So you can see here that there's always on top, it's just on a different screen. But if I like minimize this, even though it's still on OBS, oh, did it crash? Even though it's still on OBS appearing there, it doesn't like refresh as fast, which is definitely annoying. But yeah, I mean, there may be a plugin that you can use that's better, but I don't like downloading plugins for OBS. It feels like too much of a too much of a bloat, really. Like I've already got like 2 or 3 different plugins for audio, and then I don't really want to end up having sort of like 10 or 15 plugins just to get my stream going, because my CPU usage goes up by quite a lot. So I just kind of use a new window, and things like fancy zones and always on top by Windows Power Toys. It does help quite a lot. So yeah, I mean, let's find the 0 page. Oh, what did I just do? Oh, Vim, please don't do this to me. There you go. 0 page indexed, or what is it? 0 page indexed. Okay, let me just find what this function is defined, because I can't remember. We don't have IntelliSense here because I'm using C++ modules. But if you guys are wondering why I can't just find the definition of the function, and C++ modules doesn't work quite well with Clang D, unfortunately, which is definitely a low. However, if when they do manage, well, when they manage to do it, when VS Code or whoever writes the Clang D plugin for VS Code manages to upgrade to Clang D19, then there will be some support for modules. So I'm looking forward to that, really. CMP operation, CMP index. Hello, Arconaf. How's it going, dude? That's another OG right here. One of the good nights where the stars have aligned. Yeah, I guess so, dude. So you managed to catch a stream today. We're always here. Some of us just love observing more than talking. Yeah, I'm glad. I'm glad I'm not just coding on my own. It does. I'm happy that the days of coding on my own for hours until someone says hi and then leaves straight away is over. Because yeah, like back a year ago or so when I started streaming, I definitely had that problem. But you know, it's not an issue anyway. I like coding in front of people, and I like coding on my own either way. So it just means I'm a bit slower if I'm talking to people, but I can still do the work. So this is what we want to call here. So we want to do no absolute. Where is it? Where's the 0 page indexed? Where did I put it? Oh, there you go. So I want to get this function in here. Okay, so what do we have? We have 0 page. Deleted one too many. We are going to pass in the CPU to this. We're going to pass in the value of the 0 page. And we're going to check that we're going to enable the profiler that we have at the top. And for those who don't know, we have a very cool custom-made profiler that just works with RAII. So whenever I enable this line here at the top, depending on whether or not you include the build macro for the profiler, it will profile your function, and at the end you get a very nice kind of JSON with all the, you know, this function or CMP 0 page indexed took like 10% of your runtime of your program when you emulate a program. But I can show you guys later. There's also a stream if you guys are interested in knowing how that works. You know, I've done this like many moons ago. I think it was like maybe 3 months ago or so. But it's one of the features that I actually do enjoy, and I wish I had it in every project. So auto const position. So what is the value? The value is going to be, oh, God's sake. The value is going to be, I guess, CPU.mem, and then we have CPU.reg.pc was 1 here. So it's where I am currently in the program, which is where the program counter is, which is, you know, after the opcode or in the opcode, and then +1, which is actually the 0 page address. That's what it's doing here. And this is the register I want to index it with, which I think is going to be emulator register, and we have X, right? Let me just check that though. I think it's definitely an X, 0 page X. There you go. So, and this one takes 2 bytes, of course, and then returns 4 cycles. So that's what I need to do here. So we take 2 bytes, that's already here, and we just gotta put the number of cycles, otherwise it's 0. And we haven't done it yet, but like, I'm trying to return the correct number of cycles for the functions that I can anyway. Because some of these opcodes, they have like a star next to it, which means the number of cycles may or may not be different depending on what happens. And you can read about the conditions if you want in here. But I am thinking of implementing the actual kind of, not real time, but hardware, what's the word? hardware accurate timing of these instructions in the future, which just means that, you know, based on the number of cycles that we have, we just may have to wait a little bit because believe it or not, our modern CPUs are much, you know, thousands of times faster than a 6502 CPU of back in the day. So we haven't sorted it out. Now at the moment, the emulator just runs as fast as possible, to be honest. But because we are preparing to return the number of cycles for each instruction, that work is going to become like easier in the future. And this is what this instruction config does. Okay, any questions? No questions, nothing, no messages. Let's remove these to-do comments because I think they are ready. So we have the CMP indexed, which is register. See, this one doesn't even need to be a lambda because this is only used in one mode or in one register, which is the A register or the accumulator register. So actually, let me just return this. So what should be returned here? This should be a optional of instruction config. Did I misspelled anything? No. And we can just run the function instead of like returning a lambda to it. Okay. Okay, so now I'm gonna have to compile this in a little bit just to make sure that we fix the errors because I've for sure made some errors. Oh gosh, where is it? Decrement, CMP, there you go. So supported instructions. What are we on? Now, we've added this one here, right? Which is D5. So 0xD5 is going to be CMP 0 page indexed. And this doesn't return a lambda, so it's just the function itself. Okay, CMP 0 page indexed. Now let's just build it because I am unsure if I've definitely made errors somewhere, and because we don't have IntelliSense, we won't know. Right, so what's the case here? What's the issue here? So CMP operation. Okay, so this in the previous lifetime of this block of code was being used with not a dynamic, but an input register, right? So we do need to do that in here. So I think what we do is, in fact, that's the uint because it's a register. Then we do emulator, register, or reg, right? Is that what I mean here? Yeah, it is. I mean, let me know. Does anyone know what the syntax does in C++? This is an interesting one that always comes about. Whenever I use it, people are like, what the hell does that mean? So if you can understand this syntax here, let me know in the chat. And if you know, you get a shout out. I can't really give you a prize because I'm poor and I don't really have any money. I don't get any money from the stream. But if I did, you'd get a prize. But anyway, if you guys know what this means in C++, I would be interested in knowing what it does. I mean, I do know what it says. I do know what it does. I want to know if you guys know what it does. I have no idea. Yeah, so let me see if anyone else is going to guess. Because if not, I'll actually explain it because you guys have been watching me write this all the time and then you probably don't even know what this does. So, right. Let's take a look at what struct register, what this register struct is. I can see a cast unsigned bit integer. Kind of, yeah. You're kind of there. Kind of far still though. I'm not gonna lie. But we do have a struct called registers here, and if you look at this, registers is basically just a struct. Oh, let's see. Most C++ seems alien to me. These make absolutely no sense. Just watching carefully in case something clicks and I suddenly begin to understand it. Yeah, dude, I'm sorry. The stream is probably a bit alien because it's mostly low level, but yeah. Anyway, so we've got this struct called registers here. And it's basically just a pack of uint 8 and a uint 16 in there somewhere, right? So it's not that interesting anyway. And just know what that is. But when we do something like this, right? So when we say we want registers, : and then a pointer to a member that is of type uint 8, we are essentially allowing the caller of this function here, CMP operation, to say which member we're going to use for this register here. So essentially, you can dynamically define, or you can change which in this case here, which register we're going to use for the check. That's all it does here. And the way you use it is by doing this. So you make sure that your pointer is dereferenced first, and then you do a dot on the thing. Otherwise, because of the ordering of pointers and the dot operators here, you just have to do that. But that means that I can pass something like, let me just do I can pass in something like this. So I can registers and I don't know, SP, right? So if I wanted to change to check against the stack pointer, I would do this, and my CPU is going to be dereferenced on the stack pointer instead of, you know, something fixed. That's the best way to learn. It's like the colon the C. Is the colon like the C in C#? So no, the colon is a scope thing really in C++, right? So I have a namespace called Emulator. So this is saying registers is inside the emulator namespace, and this reg here is inside my struct registers. I think that's kind of the easy way to understand this if you don't really know C++ well. But yeah, man, this is ridiculous syntax that you look at it in C++ and you think, how does that work? How does that compile? And what does it do? Oh yeah, it's like the same thing as a dot. Yeah, it's kind of the same thing as dot. Yeah, so dot in C# and Python, they also mean like namespace, right? But in C++ we have different meanings. So we do have a dot in C++, so you can call, you know, CPU.reg, and that will be like the register inside the CPU variable. But when you have like namespaces and static variables in a struct, or you just want to refer to the type of a variable inside the struct, you have to use the colon here. So yeah, it can be a bit confusing because of that, but yeah. But anyway, let's continue to do what we're trying to do here. So I believe that this should sort things out now, and we don't want to return this anymore. In fact, we don't return anything. So it's just a void function. It doesn't return any type. We obviously have to kind of say which register we're trying to compare now. So we pass in the reg, I believe it is, which is just that type. And we have to pass in reg in here too. CPM indexed. Now this is where it gets interesting. I'm going to have to pass emulator registers. And we have A, right, for the accumulator here. Yeah. And the same thing in here. This is just the reg, I believe. Now we should be able to get further with the build at least. So is it a destructing a struct? Kind of, yeah. So you're saying, yeah, I guess you can see it like that. So you're destructing a struct and passing which variable you want to use from that struct inside the function. So something still failed. What is it? Let's go to the first error, always the best. No matching function call for CMP operation. No candidate function. No non-conversion from element type, aka constant unsigned character, to uint registers and second argument. Huh? What? I guess, do I do this? Will this work? See, it's so complicated that even I get into a pickle with it. Expected a qualifier ID. But in theory, reg should work here because I'm just passing this down. Will that work? No, that's not going to work either. I have to do the opposite now. So instead of deconstructing the struct, I have to reconstruct it and pass it down in here, which is interesting. Why don't pass in a reference instead of a pointer? These are all references, yeah. This is not a pointer. This is not a pointer. This is what I just explained. So go back, rewind 10 minutes, and then you can look at the explanation. So CPU media index, yeah. I thought that just reg would work here. So is this CMP operation? CMP operation. Oh my god, CMP operation. There you go. This is taking... Ah, okay, he's on the second one. That's why I can't pass it, because it should have been here. Just looking at this and like, this should work, right? This should 100% work. Yeah, let's flip these in here as well. Oh. Was that the last one? No, of course it isn't. And we're fine now, right? Yo, late today. Hello, Mr. Incognito. It's good to see you, man. It's good to see you regardless. And please like the video, guys, if you haven't done it yet. So, yeah, we don't want to profile this one. Wait, what? No, we do want to profile this one. I just didn't pass it here. Emulator.cpu, CPU. There you go. That's a little bit better. And then we obviously have the program size as well, which is, oh gosh. Give me an example of why this is used. There you go. So spam of const.std uint8 program. So this is an std spam of const.std uint8t program. And we don't need the reg in here, right? We don't need it indexed because this has only been used for the accumulator. So really, this would have been A in the first place. Oh no, this is X, and the one in here is A. Yeah. Right. We're getting closer and closer every time. If I can make no typos. There you go. So I think we're linked now. Yeah, it just goes to show you guys that, you know, why having something like IntelliSense is really good. You know, why having something that's constantly compiling your code and giving you feedback on lines that don't build is good. Because if you don't, then you have to do a bunch of shit like this, really. And I kind of shot myself in the foot by using C++ modules, really. I could have just built this as a normal C++. Well played, GG, easy C++ dungeon. Yeah, man. Hello, Al. How's it going, dude? It's good to see you, man. Long time no see. I started getting back into Urchin, man. So I need you on the streams now. I need you on the streams to make me not do crazy things in Golang. Because I've been writing so much shit. It's ridiculous. So we have just added a 0 page plus X. So which one is that? That is D5, right? So that is D5. Where are we? So D5, this one here. And we now have OK in here. So we have OK really means we have the code, but not the tests, right? So we're definitely not following test-driven design here, guys. So I do apologize. I'm writing the test after, like a Chad. Okay. And yeah, let's continue. So next one, on to the next one. Let's not stop. Let's not stop. I believe in you. You can do it. I wish I believe in myself as well, man. So, so we've got absolute, we've got X. We need to do the absolute plus X now, which is kind of the same. And there's two of them. They're both 4 plus whatever. Okay. So let's go to that. CMP 0 page indexed. Why is my Vim bindings just been so slow today? So we're going to copy this, right? We're going to copy this. We're going to put it after the absolute one. We're going to call it CMP absolute indexed here. Now the thing is, this should really, oh no, yeah, no, let me copy from the other function. This is not the right one. This should actually return an instruction function. And the reason why is because I'm going to return the same lambda with the only change being the register I'm going to index it by. Because I have two modes here. I've got the same mode with two different registers. So I can index it with X or I can index it with Y. So this is useful because it's the same code. It's going to be the same code. The only difference is the register that I'm indexing it by, right? This is it. So we're gonna do that. Now, we do have absolute indexed in here somewhere, right? Absolute index. Let's just copy this real quick. This is what we want to do. So we want a +1, +2, and then the index. And let's call that the index in here as well. We don't need that. That's for losers. And that is it. We take 3 and then we do 4 plus byte plus the cycle add, I guess. So yeah, I mean, I'm not sure if I explained here, but every opcode in 6502, or not every opcode, but a bunch of the opcodes, especially in more complicated addressing modes like absolute indexed, where we will index the address you give it by a register, they will have some caveats. And the caveat is that you may actually have, more cycles than what is specified here. And this can happen if, the address that is, the index is in. So once you index the stuff, if that address is on a different page in memory, then you add a cycle to that operation. And that's the problem here. And we don't have anything to do that right now. I'm just going to try and put some to-dos here. But yeah, I mean, in fact, it'll be std size t, because it's a type. This is obviously not used, but this is obviously not set, but this is the goal here. And we're gonna have to basically set the cycle add to 1, based on whether or not that index went to a different page, right? And you can check out our pages. I'm not gonna explain that. I guess you guys are familiar with that, right? Well, we can talk about page anyway. But once you go from like 00 to FF, all of those 256 memory addresses is a page. The next one, the next 256 addresses will also be a page, and so on and so forth. The 0 page has a special number, has a special name. The 0 page here, as you can see on the screen, is the first page, and it tends to be the faster page to access, I believe. And we have like special addressing modes that will operate on the 0 page. So, that's why the 0 page is important in 6502. But yeah, I mean, just know that there are some caveats and we haven't really done them yet. So this is CPM absolute index, or in fact, should be CMP absolute indexed here. So we can now add the CMP. Let's go back to here, and then we can add 2 of them, right? So we've got 2 opcodes in one go, because as I said, we have 2 opcodes that use the same addressing mode, but different registers. One of them is DD, which is X. If I put that in here, that would be a joke, but anyway. CMP ABS indexed. And this time, this function is returning the actual lambda that will handle it, so the actual instruction function. So I do have to pass in emulator registers and X, which is the one I index things by, right? And then the other one will be D9, which is the same as this, I guess. Oh, in fact, can I just copy this? Ooh. And then change this. And now we've got DD and D9. We can just mark it off in here. So DD and D9, these are the two. We need to define that, and then OK here. Now comes the kind of interesting ones, really. So these ones are kind of interesting ones. This is where we have proper indirection. So these addressing modes here, this first one is called indexed indirect. So we take an index first of the 0 page, and then whatever memory is on that 0 page address, that is used as the absolute value to get the actual memory that we want. So it's like an extra indirection here. And we have the opposite. So we have indirection index. So indirect indexed, which just flips the order of the operation. So instead of like indexing the address first, we indirect whatever 0 page address we have first, and then that will point to a absolute address in 0 page. That address is then added to Y instead of done it before we actually, indirect. So this is why this is called indexed indirect, and then this is indirect indexed. That's the caveat here. Oh gosh, I feel like I'm talking too much. Should we take a break? Should we take just a chatting break? So how are you guys doing? Is everyone understanding what I'm doing here? Do you guys want to ask me anything? Feel free to do it right now while I'm drinking some water. This water is really good. Water never tastes like the same as when you're absolutely thirsty after talking for like half an hour. I'll tell you that. Oh. There's only one thing that could beat it, and that's Coke Zero. I love Coke Zero. Unfortunately for you guys, I know we never got sponsored by Coke Zero, so I never bought any more Coke Zero, if I'm honest. Coca-Cola has hurt my feelings by not sponsoring my channel that gets 10 viewers on average on a stream. But yeah. Anyway, I feel like we should probably keep going because I'm talking too much trash. Yeah, so I guess it's more of the same here, really. So we have CMP. Ooh. I don't know why, but the Vim binary is just being ridiculous. Arconav, will you also create emulators like other well-known ancestor chips in those old machines? Like the VIC chip, for instance, in Commodore 64? Maybe. I don't really know that chip very well. I have heard of it, the VIC chip. But yeah, I'm thinking of doing Z80, because Z80 is quite... because it's so similar to 6502, to be honest. So it will be quite an interesting one. But also Arconav, I'm not sure if you were here before, but I was just talking about how all of these operations, all these opcode functions, are essentially like grabbing the address mode that you want and the operation that you want. So you can kind of plug things in and out, which means that I can abstract that and provide just like a backend for people to define their own emulators. And I think that would be a really cool project. So like, given a backend where you can have an emulator entirely described by a JSON file, for example, right? And then at runtime, at the startup, the emulator will be created based on like the addressing mode that you want, the operation that you want, and the flags that will be affected in a particular CPU in an architecture. But that definitely feels like a different beast to what we're doing right now. That happens a lot in VS Vim motion. Yeah, Mr. Incognito. So like what I'm finding now is like whenever I try and find something, so say CMP ABS, like I don't know what the hell's going on, but it just takes ages. Maybe I can reload the window. Let's just reload the window. Maybe they'll like clear whatever cache it's holding or whatever the hell it's doing in the background. There you go. Much better now. Instant. So yeah. So Arconav, I'm actually interested. Like, what CPU did you grow up with? Did you grow up with, my man? I'm gonna guess it was a Commodore 64 since you mentioned it quite a lot, right? Unfortunately, that was before my time. You see, Commodore 64s and BBC Micros, which seem to be a very kind of solid machine, actually, the BBC Micro. And another one that you guys probably don't know that much in America or outside the UK, but one that was very, very popular in the UK was the ZX Spectrum. So the ZX Spectrum was a machine like ahead of its time. Not in the sense of computing power, because it was just an 8-bit machine, really. But it was so easy to create programs for it. There was so many programs and games created for it, just because of, It was easy to develop software for it. So I intend to. I've actually been looking at buying one, but they're quite expensive online, if I'm honest. So we can take a look on eBay. Let's see if we can find one. I couldn't find. Last time I looked, there was one for like £200 in very good condition, but I got outbid by someone else. C64, yeah, 6510, which is some version of 65. Yeah, 6510 is the same version that the NES has. It's just like a few modifications to some of the instructions. But let's see if we can find a ZX Spectrum here. There you go. So there's no bids at the moment. When does it finish? This I'm not sure in what shape this is in, but this machine I've always wanted to buy and just keep around because yeah, apparently it was amazing to have one. Oh, this is the original with the box and everything though. This is not too expensive. I mean, not too shabby. The only thing is the condition. I mean, some of these don't look that good, you see. But I'll tell you what, man, if I was born in the 80s and I had one of these, I would be such a good programmer right now compared to what I actually am. Because you have to do everything in either assembly or basic, right? Which is, basic is alright, I guess. It was the Python of its day. But it teaches you a lot of things about the hardware. But anyway, you know, this is, and I think this has a Z80, does it? ZX Spectrum? Let's see what CPU we have here. I also dream of one day having the means of finding and buying an original C64. Yeah, dude. I mean, at least you know these devices will maybe like I don't know. I'm gonna say like £80 when they come out, so they're not quite expensive. But the Commodore 64 was a full-on machine and way more expensive, right? So I guess they will be maybe like £500, £600 now here in the UK. But what was the CPU? Let's see. Yeah, there you go, Z80A. So yeah, this is the next one I plan to kind of learn about and program. So this guy here was in a lot of different computers and video games. But add many nice features of the Motorola 68. Is it? It is an 8-bit machine, right? Yeah, 8-bit machine, any 8-bit processor. Yeah, I mean. Anyway, let's continue doing this. So we are looking for CMP absolute indexed. What we will have now is the function called CMP indexed indirect, as I said. I completely misspelled the indirect word here. Actually, before we go, I'm actually just interested in knowing how much a Commodore 64 is. How much more expensive are they compared to the ZX Spectrum? These are the mini. You don't want the mini though. The mini is like, what the hell is this dark mode? Can you guys see this dark mode? Ridiculous. They don't look that expensive, Arconath. I mean, you can definitely buy one if you save up for a few months, dude. Right? You got a dev salary in Turkey. Not too bad. There are some new versions, the mini and the whatnot. I would like to find the OG. Yeah, me too, dude. Like, even for things like the PlayStation Mini, which is something I actually grew up with. I had a PlayStation. That was my first ever like computerized thing. I would never buy a mini. I would just go straight to buying the original. There's no essence. There's no soul in buying the mini, right? It's just someone else's marketing gamer getting more money from ripping off the an old architecture. But yeah, they don't look that bad. Otherwise, I'll buy a Commodore X16 or something. Fair. CMP index and direct. And what are we going to do? So we're going to pass the CPU here. We're going to pass that in here. And then we also have the spam of the std uint t const program. I think that's all we need, right? And then this is where we do the fun thing. So we are actually going to copy from the 0 page because that's what we get. We get a 0 page address. Oh, we're here already. Didn't even notice. Here, yeah. So this will be the indexed indirect. Yeah, that's the one. And the indirection will be X. Yeah, for this case. And the CMP operation, which is CPU-M, okay. This takes 2 and returns 6. 6 cycles this takes, okay. And it's more of the same for the indirect indexed, right? The only thing that changes is the function that we indirect with. Indirect indexed. Okay. And this, I'm pretty sure this changes as well, though. Okay, yeah, so we do have indirect index. I'm just making sure that we actually do find it somewhere. Okay, good. And now we can... Oh. We can add them here. And that's it. Now, first one is C1, which is index indirect. C1, CMP, indexed indirect. And the second one is going to be CMP indirect indexed. Okay, yeah, I think that should compile, right? Except we haven't changed the opcode for the last one, which is D1. And then I'll teach you guys, or I'll take you guys through the test if you're interested, so we can start adding some of them, I guess. What do we have here, though? What is the issue? No matching function for indirect indexed. Huh? Indirect indexed. Okay, yeah, we don't pass the Y. I think it's inferred. It's always inferred. There is another one here, though. So indexed indirect. Yeah, we also don't pass the X register. I'm not sure why I passed it here, to be honest. And what is this problem? Is of undeclared identifier reg in this case, which is the absolute indexed. Absolute indexed. That should have been indexed. Okay, I think that will be mostly right. Maybe, maybe not. Maybe yeah, maybe not. Yeah, that'll be right now. Emulator was misspelled here. Okay, so now what is complaining? No viable overload for this, aka no known conversion from CPU. What the hell am I doing? It should have been put position here. Oh, position. And with a bit of luck, we'll be able to to have that now. There you go. So that worked. I think, right? What I love about these streams is that, one, this is pretty chill because it's like I'm not really thinking hard about what I'm doing here because I kind of know this project very well, and it's, you know, every feature that I add is basically the same thing over and over again with a, you know, very minor changes. I get to talk to you guys on the chat, which is always good. And most importantly, I get to actually push a lot of stuff down to my GitHub. So it's always active. And that's what I'm going to do right now. So I'm going to, first of all, push this up to a branch, and then we're going to merge this in. Then we're going to continue with the tests afterwards, because I don't really feel like adding the test in the same PR. We'll do it separately because I wanna get more contributions today, to be honest. And we can split things. Yeah, README. We now have all of these kind of okay-ish supported. And again, okay here, if we look at this, okay means that we have the actual code in there for the what do you call it? The opcode. That's what I was looking for. We have the opcode support, but not necessarily the tests for it. And we're going to be adding the tests in the stream. In fact, we're probably going to use GPT to just generate a bunch of tests for us, I think, because, you know, why not? It just seems like the easy thing to do. And I want to see how good it actually is on coding. Things with Google Test and some sort of like emulator specification. But yeah, I mean, this is good. This is good stuff. Good stuff. One more format here. Format the document, and then we're gonna add everything that we need. Oh. So we had 0 page indexed. We have absolute indexed. We have, what else do we have? Indirect, indexed, and then indexed, indirect. Yeah, that's it. Oh no, what the hell? What do we have now? Okay, yeah. There's no new line in there. That was just a random new line in my thing. Use Claude instead of ChatGPT. Is Claude better? Is Claude actually better? I'll use it today for you, dude. I'll definitely use it today for you. It's like the second time I think you're mentioning it on the chat, and I never really used it, to be honest. I always use GPT because, well, that's the only one I kind of knew, to be honest. I know of Claude, I just never used it. Is it better than GPT at coding? That's my question. Let's push that and then also create a PR and so 65K. Oh, hello, Brock Daniel. Way better. Oh, I didn't know that. Yeah, I'm going to start using that then. Right, so we're going to create that PR. We're going to let the pipeline do its thing. So I'm not sure if I've mentioned it, but I have added a pipeline now. So you guys can see that this project gets built automatically, tested, and yeah, not much more to it. And formatted automatically. We check the formatting of things. Which brings me to my next point. I will be doing a series of videos on automation in pipelines. So if you guys have any kind of requests for what you want to see in that, let me know. But the plan is to essentially teach you guys how you can create your own GitHub pipeline, how you can create your own build pipeline for Rust, Golang, and C++. I'll be doing both, all of these languages at least. Some sort of like fail fast where you'd be like kind of, I guess, linting code and making sure that you run static analysis, and also a test build, and that will be the whole kind of series. So you'll be able to do it yourself in your own projects, because it's something that is very useful having whenever you have a project that you share with other people. You want to make sure that no one breaks the build, right? You want to make sure that the code is up to standard. And having pipelines is very useful for that. And also, if you don't have a job, knowing CI/CD will help you out quite a lot getting a job, because every company uses it. And you can ask any of the guys here on the chat whether or not they use CI/CD at their work, and most of them will say yes, hopefully, right? Unless you, I don't know. ChatGPT, good at explaining yapping code. And Claude, short, simple explanation, and way better. Let's go for it then, right? Let's try and go for it. So all the tests have been running automatically on the pipeline, which is good. Claude. What model is Claude? In fact, who owns Claude? What company owns Claude? Yeah, go on. I'll give you my data, Claude. Don't worry. Oh my god, I have to put my phone number on everything. What the hell? Wait, you guys can't see this, right? I'm on the net. Let me just check that I'm not gonna dox myself now. Good, yeah. Just give me a second, guys. I'm literally just kind of. I agree, I guess. Let me send my verification code. This is so annoying. They now want your phone number as well. Right. So I have verify and create account. Okay, hello, Claude. There you go. We're on it now. He wants to know my full name. Oh, he's Anthropic. Okay, he's Anthropic. Never mind. Why would you do that? Yeah, I don't know. I just want to test it out, I guess. They're literally stealing all my data now. Sounds, let's begin. I just want to get into the chat, dude. See, ChatGPT, with ChatGPT, I don't have to put all of this in. He knows what's better, Perplexity or Claude. I have no idea. Right, so write some unit tests for the CMP opcode in 6502. Write some Google C++ GTest unit test for CPM opcode in 6502 with the 0 page with the immediate mode addressing. Make sure you include edge cases. Let's see how good it is. Firstly, I'll create. What the hell? This is next level. I was not expecting this. I thought it was just going to be in line. Equal values. Okay, yeah. Now, surprisingly, this is actually very similar to what my tests look like as well. This is ridiculous. This is good. This is good. I like it. Now, let's see if we missed out anything, right? So we have the class, which is a fixture. We don't want the fixture. See, this is one of the things. This is why you don't use AI, I guess, right? So, although this code looks good and it probably does work if you have a CPU that kind of fits this API that they assume here. I wouldn't necessarily put all of this into a fixture. Oh, I didn't mean to execute. I will explain. I wouldn't put this necessarily into a fixture because fixtures in tests are for when you kind of want to have a setup or a shared setup or something like that. In this case, you don't. Like, you can just create a new CPU every time. So it's not the best code, to be honest. But we can use this for sure. So like we can come down here, we can copy all of this, and I'll show you guys how this is actually done, because it's actually very similar to what I have. First of all, have we merged the PR? Because I want to merge the PR and create a new branch for this work. So okay, my pipeline passed. Yay. Now I can go and finally merge the pull request. So once I merge the pull request, we delete the branch, we can check out to main, we can pull here, and we can create a different branch straight away, which would be add CMP or compare tests, right? So this will be a new branch, and why not? Let's just push it in. And let me show you guys how it's all done, because it's actually very similar to what Claude just gave us. So I have a test directory where basically every kind of C++ file is a type of test for a particular opcode, right? So you have like the EOR 0 page here, they're all here. Yeah, and so on and so forth, right? I'm not going to explain this too much because it is what it is. So ideally, what I'll do is I would create a CMP tests if I don't already have it, or compare tests. I do already have it. I'm going to delete this because I'm going to name them a little bit differently. So let's say I compare get the flag test here. I have CMP tests, right? I just want to name it by the actual opcode name. Now, the next thing I have to do is I have to basically add it to my CMake, and I created this nice function here in CMake that takes that C++ file, turns it into an executable that contains Google tests, and the rest is basically integrated to VS Code here. So that's what we're going to do. So we're going to copy this, and then we have CMP tests. I'm just going to kind of sort all of this out because I like it being sorted. There you go. So this will trigger CMake to do its thing, and we now have CMP tests. I am basically just going to copy and paste everything that we had there. I'm going to do a few minor things. So first of all, I don't like the name that they gave us. So I'm going to change this to CMP immediate test to CMP or CMP tests. And the rest of them are kind of fine, right? So what I actually need is a little bit different than this. First of all, do I need that? I don't know. Do I need a program? Yeah, I need a program. I need to create my CPU in the first place, right? So I need to do my auto, or in fact, emulator. CPU. That creates my CPU object in this. I'm going to format this file before we continue. I'm going to load my A here, so reg.a in this case. And this loads the value 40 into A. And what I expect is that we're gonna execute a program which says C9 40, right? In my case, it's a little bit different because the program has to be an array. So we do have to have an array here of uint at. Let's put 2, which is the program. And that will have this here, right? So this is what we're going to have. Let's just lowercase everything because I can't be bothered. Okay, that's basically what we need, right? This can be a const expo. And what I do now is I execute, I do CPU or emulator, execute, CPU, and then program, I think it is. Does my execute return a flag or something? Yeah, it returns a size t. What's a size t here in this case? Return false. Return numbers of cycles. Okay, yeah, so I can check the number of cycles already in here. And the number of cycles that I expect in this case is, I don't know. I don't really know what I expect. So I have CMP immediate, is that right? Which is 2. And this should really be returning the actual cycles, which is 2. So it takes 2 cycles for that comparison. So if we do that, we expect assert true this to be equals to, or assert equals, in fact, to be equals to 2, right? That's what I expect here. And this is assuming that execute is returning a value. It is. And the number of cycles, okay. I'm not sure if this is actually working. I'm not sure if like the emulator is returning the correct number of cycles at the moment because I haven't really done any work on that. So we're going to keep it here anyway. Now, yeah, this is doing assertions here. Or expect. Sorry, yeah, this is expecting that the 3 flags are set in the following. So it expects that the 0 flag is set in this case. So 0 flag happens when they are both the same, these 2 values here. So it's going to be comparing 40 to what's in the accumulator, which is 40 as well. Because it does a minus, essentially we'll minus a, or do a minus this value. The result will be 0. So this should be set. And this should really be reg.z, I think it is. And this is the same thing, reg.n. No, reg.n. And we're expecting the non-zero, or sorry, the negative flag to be not set because we don't have a negative value. We have a 0 value. But we do expect carry to be set. I don't know why carry it would be set in this case, but we can check out the code because I don't really know. Why do we expect the carry to be set? So if we do CMP operation, so we set the carry whenever the register is more than or equals to the value. Okay, so I guess this holds in this case. So the reg.c would be a thing. But what it did forget to actually expect in this case, for my case, is all of the other flags that we don't have here. So all of these other flags will have to be set in my unit tests as well. So let me just pull the flags here. So NV, I'm just going to copy this to be honest. So I have a reference in here somewhere. I'm going to paste that here and I'm going to put that there. 1, 2, 3, 4, 5, 6, 7. Yeah. So actually, N should be first. V should be here, which is going to be an expect false. Z is going to be set for sure. Right? Then we have B in here, which is going to be false. So we're not touching those flags at all. And then we have the same thing for D and I, the interrupt flag and the decimal flag. And we have Z and C here, which are fine. So this is what that Claude thing missed. But to be fair, I wasn't expecting it to get it right either because I didn't explain the context very well. But it should have inferred that we should also, check the other flags to make sure they're still fine. So this is the kind of work that I would be normally doing here by myself. Like I'll think about all the edge cases and write these tests. But AI does help us quite a lot in this, I guess. But I'm not going to trust it too much. I'm not going to trust it too much because I'm scared that it will probably miss some of the edge cases still. So, but in this case, accumulator les, 0 accumulator, max accumulator. It seems to have got like good cases in here, if I'm honest with you guys. Yeah, because what I would be doing here is I would look at the actual operation that the opcode does, which is essentially a minus, right? So it does accumulator minus the memory and set some flags depending on what the comparison value is. And obviously, because it's a minus, I would do, what happens if this value is smaller than this one? What happens if this value is bigger than this one? What happens if they are the same? What happens if one of the values is 0? So if I have this one and this one are 0, those are, both edge cases. And also checking all of these flags to make sure they are set accordingly, right? And yeah, and I think it may have done it okay this time, surprisingly. But yeah, unit testing is definitely boring, and this is why I don't do that much in the stream because it's just people watching me do like dumb C++ code test things. Oh, let's change all these test Fs to test. Okay. Yeah, now let's go. So A should be 50 in this case. And then we do 40 in this case as well. So we execute that. And then we have a bunch of expectations. But the flags that we expect false in this case, let's just see if it makes sense. So we expect the 0 flag to be 0, or to be false. And why is that? Yeah, because we don't have a 0 value. We're going to have a minus something else, which means that the 0 flag will not be set because it's still going to have a positive value in here. So that's correct. So the negative flag, is that going to be true? No, because A is bigger than the other one, so the result will not be negative as we expect. So we expect that to be false as well. And then the carry is going to be true though. And does that match here? So if the the register, so A is bigger than or equals to this, so the carry is true in our case. Okay. Well, so far so good. So far so good. We're gonna pull some of this code in here as well. Create a CPU that we want. Yeah, so create a CPU, and then in this case we're gonna do 30, which is less than 40, so we expect a different set of flags, I guess, right? Yo, bro, what the hell? Wait, did I do that right here? So this should have been emulator.execute. Execute. That's what I meant. We got the CPU here and the program. Actually, we should have done this everywhere as well. We got that there. We got that there. Remove that one. Remove that one. We're Gucci. Yes. So now I expect carry not to be set, right? Because the register is less than the value. Oh no, that's just before. Yeah, the register. So carry is not going to be set. Zero is also not going to be set, hopefully. Yeah. But negative will be set. That's the difference here. And we're getting to the end, and then we're going to run this, and hopefully it's just going to work, and then we'll call the stream, hopefully. And the same thing here. Bring in that CPU and the assertion of the execute in here. Except in this one here, we're going to put 0. And it's more of the same, right? So 0 flag is not going to be set. Carry is not going to be set, but negative will be set. That's what we expect. So it's exactly the same as this one here. That is it, really. And the max accumulator. So we have equal values. Yeah, the max accumulator. I see where this is going. I mean, this actually did a pretty good inference of the edge cases. It did miss a few, though, and we're going to go over those in a second. But it's just more copy and pasting, really. This should have been FF. And this should have been FE in here. And we expect false, 0, 0, but we expect true. So everything is false except the carry. Okay. Yeah, I know it's annoying to give you a number, but I think I got the message already. Sorry, for some reason I thought it was a new message. I mean, the chat has been way too quiet. The chat has been way too quiet. It's worrying when it's quiet because maybe it isn't working. Maybe I'm not online anymore. Who knows? So in this case, we have 80 negative result. We already have the negative result, really. No, it's working. Thank you for confirming. You are online. Yeah, I just checked as well. So this is what I can. Well, I can't show you what I can see actually because I've got the YouTube like studio thing on it, and that has some keys on it. So I don't really know how I haven't not doxed myself, but like leaked my stream keys yet because I've got it on a different screen all the time, and I drag and drop that screen. And yeah, I mean it's a miracle that hasn't happened yet. Just a miracle. Execute. So the only thing that is true here is the negative in this case. The only thing that is true is the negative. Oh gosh. Okay. And then last one. Oh no, we still got more. We still got some more. So this should be 80. This should be 80 as well. Yeah, this is the same. Like, you see what I mean? Boundary case here is the same as when they're equal. There is no difference. So we got that one wrong as well. Negative result is the same as the accumulator smaller, maybe? Accumulator less. There you go. It's the same. So really, I don't need that test twice. And we wrap around. What are we doing here? We execute. What? Yeah, and this is the same as the negative case, which is the same as when A is less. So really, these are all the tests that we need, right? Now, if we build this, let's see if we can run them and if they work. And if they work, I can call a night very early. If they don't, we'll fix it. And of course, if they don't build, then we're going to be here forever. So. Oh, these are flags anyway. So, oh yeah, there you go. So I got something wrong already. CPU.reg, we're going to change it to CPU.flags in the whole document. Okay, that's better. And something didn't build. Let's figure out what didn't. In the sea of errors in C++, why didn't that build? Oh, it does say here, right? Oh, no. This should have been reg. This should have been reg as well. This should have been reg. And this should have been reg. Okay. My bad. It's getting to that time of the day where I'm like really, really tired and I'm not really kind of focusing. Well, I am focusing on the code, but it's difficult to code for the 15th hour of the day, I guess, right? The flags are registered. Indeed, yeah. Okay, now can we run all of these? So we have the tests here. Let's just do a global search for all the tests. Discovery. And then if we do CMP tests, we have a bunch of them. And let's just run one. Let's just try the beak. There you go. And all of them seem to run. Yay. So all the tests passed. I would say that overall, Claude kind of did give me the good solutions, I guess. It didn't, it didn't really give me distinct cases, unfortunately. And it missed out when one of the values is 0, for example. So when the operand is 0, when it doesn't do anything. So that's a nice case, right? So what happens when that's the case? So it can only be equal to... Yeah, I mean, that's not an interesting case anyway. But yeah, I mean, it gave me some repeated ones, which is interesting. Hello, Stefan. How's it going, dude? Nice to see you working on the emulator again. Yeah, indeed. We've been working on this for like nearly a couple of hours now. And yeah, we're getting some progress. What can I say? We're getting some progress. So ideally, what I would do now is like I would just replicate these tests for the 0 page. For, you can see it's very, very repetitive. So I don't want to make you guys sit here and watch all of that. So I'm not going to do that in the stream. I'll do that off the stream. But it's basically just like copying and pasting this and then changing the program code here to be for example, the 0 page, as well as adding, the particular memory that I want to test somewhere in the 0 page, and kind of rinse and repeat for every, addressing mode that we have. I feel like I'm gonna call it here, guys. I'm exhausted today. I would like to keep going for 2 hours, but yeah, I mean, I had a long day at work today. It was the first day of the week where I'm actually doing exercise as well because I don't do it on Monday. So I'm physically exhausted. My mind is exhausted as well. Thank you all very much for watching today, and I hope you guys learned something. I'm sorry, Stefan, that you just joined, but I'm having to call it now. Maybe next time, dude. Well, you can catch up on the stream though if you want. Thank you, Mr. Incognito, Arconav, Al, all of you guys. If I missed your name, Anton as well joining. Like the video before you go, and have a good night. Bye bye.